the review package that you are going to receive is going to contain a couple of things. Okay, the review package is going to contain, first off, kind of an outline, and then I'll go through a more detailed outline on Friday in our unit exam review, give you an idea how many questions, what they're on, okay, that kind of thing. There's also some suggested activities, a few kind of practice activities to do, and then the last bit of it is old multiple choice questions that have been on my tests in the past that I don't use anymore, and some old written response questions that have been on my tests that I don't use anymore. Okay, it would be highly advisable for you to do at the very least those questions, all right, because my tests are admittedly a bit formulaic, which means I basically ask the same kinds of things in different ways every single time because I have to. Okay, I'm required to test you on certain things. So if you do the multiple choice questions that I've included, okay, they're going to be very much like what's going to be on the exam because, well, the same guy made them up. Okay, and they're going to be on the same stuff because, well, it's Science 10 and that really hasn't changed in about 10 years. Okay, the other thing is the same with the written response. You're going to have, okay, those kinds of things. Graham, you can let her in now. Okay, the written response are going to be on the same kind of things. Okay, they are going to be on. Okay. Or Graham. I'm starting to think he might be accident prone. Okay. All right. So the written response sample questions are going to be very much like the written response questions that are going to be on your unit exam. I'm going to ask you to balance reactions, and I'm going to ask you to predict reactions. I'm going to ask you about solubility and all that kind of stuff. So really make sure that you do those things at the very, very least. If that's all you do, it's not great, but it's better than nothing. Okay. My suggestion would be, over the next few days, practice things. Okay? Chemistry is very skill-based. All right? Reading your notes, it's valuable, but it's not the most important thing you can do. All right? In biology, reading your notes until you can actively regurgitate them onto a piece of paper for me to read, that's okay, but that's bio. Okay? Chemistry is about, I can do this and I can show it to you. I can do this and I can show you that I know how to do that. Okay? It's all skills. You got to be able to demonstrate those skills to me. Okay? Those skills would include naming compounds, writing their formulas, predicting reactions, balancing reactions, and what we're going to go over today, the mole equation. Okay? Those kind of things. So practice some. Do you need to be doing hours a night for the next 6 nights? No, you don't. Okay? But you should be taking 10 or 15 minutes to practice some things towards your test. Okay? If you do that, on Monday night when you're really putting in your big effort, you're going to find that you don't need as big an effort because you're going to be going over stuff and going, oh, well, I remember how to do that. I just did a few of those. And I remember how to balance these equations because I've been doing that for a few days. And you'll feel confident. And that's important. Okay? You want to come into a test feeling confident. And if you prepare well ahead of time, you get that feeling naturally. Okay? If you wait till the night before and you cram, then you're going to get that really awful feeling you associate with tests. Okay? Nervous. I feel like I'm going to forget everything. You know what? If you cram, you're going to forget everything. Okay? That's what cramming does. Cramming tries to cram as much information as possible into your short-term memory. Short-term memory is exactly that. Short-term. Lasts about 20 minutes. And is really good at remembering the first 2 things you taught it and the last 2 things you taught it and forgetting everything in the middle. Okay? So don't cram. Take it from a guy who was awesome at cramming. I was also awesome at blanking on tests when I went into them because I crammed. Okay? So yeah, you don't want to do that. It's not an effective way to study. Okay? Everybody with me there? All right? So take a little bit of time each night. I'm not saying devote your entire life to studying chemistry for the next 6 nights. I mean, if you do that, you're probably going to do really well, but you don't have to. Okay? Take a little bit of time each night. Okay? All right. So I will give you all of that stuff at some point while you're working today. What we're going to start now is the last thing in this unit, which is the mole equation. All right. So notes, package, lesson 21. Take it out. Follow along. All right. There's going to be some things you want to run. Bridget, question. I am. Oh, okay. A feel better card. All right. So, listening here, guys. The mole. Okay, the mole is not an animal that burrows into the ground. The mole is not something on your face. Okay, the mole in chemistry is a way to measure or express the amount of something that you have. All right, so if I say I have 1 mole of oxygen, okay, I mean that I have a specific number of oxygen atoms or oxygen molecules, as the case may be. Okay, that's what I'm saying when I say I have a mole of something. All right, it's just like if I say I have a dozen donuts. How many donuts do I have? 12. Okay, a mole is a specific number, just like a dozen is always 12. Okay, that's the thing we have to remember. A mole is a specific number of particles in the same way that a dozen is a specific number of eggs, donuts, whatever. Okay, everyone follow me so far? Okay. All right, so that's what we have to understand. It's a unit for measuring the number of particles. There's other ways to measure the amount of something. We could use its mass in grams. We could use its volume in liters. Okay, but when we're dealing with chemistry, sometimes we actually want to know how many particles there are. But here's the problem with that. Are atoms and molecules really, really small? Yeah, they are. Okay, so we need a number that's representative of a gargantuan amount of them, and that's what the mole is. Okay, a dozen always represents 12. Well, a mole always represents this many. That's 602 with 21 zeros behind it. Big number. Okay, seems like a really, really big number, but when we're talking about particles, it actually doesn't end up being all that much. Okay, for example, if I have this many molecules of water, I have 18 milliliters of water. That would be like if Sadie took like the cap off of her water bottle and filled it with water. Okay, it would have about that many molecules of water in it. Molecules are kind of small. Okay, so when we're dealing with even small amounts of something, we're dealing with huge numbers of molecules, and that's why the idea of the mole was developed. Okay, point number 2, we're going to understand the relationship between moles, mass, and molar mass. That means we're going to have to use the mole equation to solve problems. The mole equation looks like this: N equals little m over big M. Because in chemistry, they aren't very creative. We have 26 letters in the English alphabet. They had a 3-variable formula. They used the same letter twice, and the only other letter they used sounds like the letter they used twice. N equals little m over big M. Yeah. Okay. Yeah. Not good decision making, but that's what we got. Okay. So in the mole equation, N is the number of moles. Little m is the mass in grams. Capital M is molar mass. That is the mass of this many atoms of something. Okay, we'll talk about all that in a minute. It sounds a lot more complex right now than it really is. Okay, all right, questions so far? Okay. N is the number of moles. Okay. All right, so we can express the amount of a substance in grams, we can express it in liters, we can express it in moles, okay? Liters, tons, whatever, okay? We got lots of ways to express it. But the problem with atoms and molecules is that how small they are, okay? To physically count particles is first off impossible because we can't see them, okay? And secondly, would take you several lifetimes. All right. Imagine if we have the bottle cap here full of water, and you can actually see individual water molecules, and you're picking them out with a tweezer somehow, okay, and counting them, right? So you'd be like, 700 billion, 201, 700 billion, 202, 700. What's that? Crap. 1, 2, right? Okay, you just wouldn't want to lose count, right? Okay, if you lost count, you have to start over, right? You'd die before you got the job done because it would take you that long, right? So yeah, we can't realistically do that. So we have this very large representative number. Okay, everyone with me there? Now, the reason, or the way we came up with this number, because you look at this number and you go 6.02 times 10 to the 23. Couldn't they pick like a round number? Wouldn't like 5? Okay, wouldn't that make more sense? But in actual fact, this number was arrived at very scientifically. Okay, the guy who came up with it, his name was Avogadro. What he did is he took 1 gram of hydrogen gas. Okay, and using what they knew at the time of the mass of 1 proton and the mass of one electron, which is all there is in a hydrogen atom, one proton and one electron, it's the simplest atom, he figured out how many atoms there would be in that 1 gram of hydrogen. Okay, it ended up being this many. And then he said, I'm going to organize all the rest of the elements by mass, and I'm going to use this many atoms to be my representative number. All right, so this many hydrogen atoms weighs or has a mass of 1 gram. Okay, this many, let's say, helium atoms has a mass of 4 grams. Okay, that many lithium atoms is 6.94 grams, and so on and so on. So these numbers here that are on your periodic table, they're in the top right-hand corner. Okay, that represents the number, or sorry, the mass of 1 mole, that number of atoms. Okay, make sense? All right. Okay, so that is Avogadro's number. If you ever hear me use that term, that's the number I'm talking about. Okay, and Avogadro's number is the number of particles in 1 mole, which we abbreviate MOL because we're very busy. We don't have time to write the E. Okay, everyone laughs when I say that. Guys, we have an abbreviation for AT. Okay, we're obviously very busy. We abbreviate words that have 2 letters. Okay, all right. So yeah, that's the representation. Okay, so the mass of 1 mole of a substance is the substance's molar mass. So it's telling us here, what's molar mass? Well, it's the mass of 6.02 times 10 to the 23 particles, whether they're molecules or atoms, of that particular substance. Okay, we can figure that out using the periodic table. So let's say I want to figure out what the mass of 1 mole, or 6.02 times 10 to the 23 molecules, of water is. Okay, I want to figure out what that mass is. So what I do is I look up first water, okay, and I write down its formula. Water contains 2 hydrogens and 1 oxygen. I look at my periodic table and I know that the mass of 1 mole of hydrogen is 1.01. How many hydrogens are there? 2. So I go 1.01 times 2, and I add that to the mass of 1 mole of oxygen, 16 grams. Okay, if you look on your periodic table, that's what it is. Okay, so that means that 1 mole of water has a mass of 18.02 grams. Okay, some of you are looking at me crazy. Okay, this is 1.01 times 2 is 2.02, right? Plus 16 is 18.02. Okay, Megan. On my chart, they've got way more decimals. Yours doesn't have all those. On yours, yes. Yeah. Okay, that's why I use the numbers that are on yours. Yeah. Yes, grams per mole. Okay, so this is the mass of 1 mole. Everyone follow me on the units there? Okay, so mass of 1 mole. Okay, is that pretty straightforward how to calculate that? Sadie, question? You'll be fine. Yeah, but it'll take you so much longer. No, it's on your periodic table, and you'll always have that. So no, you don't have to memorize them. Okay, does everyone follow how we would find molar masses? Right, you're always going to be able to find that part of the mole equation because you'll always have your periodic table. So that's something you won't have to use the formula to calculate. You'll just use your periodic table. Okay, so here's what I want you to do. Okay, there's 5 examples here. I want you, using your periodic table, to calculate the molar masses of these compounds. They obviously get a little trickier as you go along. Okay, so I'll give you a few minutes and then we'll try like the first 2 or 3 together. Now, incidentally, since we're doing some calculating, what do you probably want to have with you on Tuesday? Yes, you may not, I repeat, sorry, Tuesday, may not have your phone as a calculator on Tuesday. I collect the phones in a Rubbermaid bin prior to the exam. You do not have them for the exam. Please bring a calculator. It does not need to be $180 Texas Instrument, whatever number we're on. Okay, used to be 80, now it's like 90 something. Okay, whatever it is, 84. Okay, you don't need a graphing calculator. I mean, if you have one, it'll work definitely. It'll be overkill, like swatting a fly with a sledgehammer. But okay, you just need a basic calculator. Okay. Just a basic calculator. Yeah. It doesn't even have to be scientific for really what we're doing. Well, sorry. It does need to be scientific. I take that back. It does need to be a scientific calculator. Eli, yes. Okay, so give these ones a try. Show you one more? Okay, I'll show you. I'll go over number one. You can use your phone for today. Okay. All right. So if I want to calculate the molar mass of sodium chloride, okay, first off, I look at the formula. How many sodiums are in it? 1. Okay. On my periodic table, the atomic or molar mass of sodium is 22.99 grams per mole. Okay? And how many chlorine are there? 1. The molar mass or atomic mass of chlorine is 35.45. Okay? So I simply add those two together. Okay, so 22.99 plus 35.45, 58.44, okay, 58.44, what are my units? Grams per mole. How important are units? Very important, because without them, that answer would be wrong. And you would get no marks for it. Here's why. I would look at it and go 58.44, what? Okay, apples, oranges, elephants, old ladies in wheelchairs, I don't know. Okay, you don't put units on it, I have no idea what it means. Okay, so make sure you put units on it. Okay, let's have a look at number 2. All right, so on number 2, we've got iron and bromine together. How many irons are there? 1. Okay, so we got 55.85. Is that right? Okay, and I'm going to add that to how many bromine? 3. So 79.90 times 3. Okay, I got to make sure I multiply and get the right mass for bromine before I add it onto this. All right, so when we do that, okay, we got our 55.85 plus 79.9 times 3, 295.55. Grams per mole. Okay, all right, give you a couple more minutes to get ahead of me again. Okay, so for number 3, okay, I've got 2 phosphorus. They're what, 30.97? Okay, so 30.97 times 2, and I'm going to add that to 5 oxygens, so 16 times 5. All right, so 141.94 grams per mole. Okay, everybody with me there? All right, now here's where it starts to get tricky. If I have a polyatomic ion like ammonium here or sulfate here, all right, I can't find molar masses for ions. They're not listed on there. You have to do it element by element. Okay, so what I have to do is look at this. This is saying that there are 2 ammonium ions. Agreed? Okay, so how many nitrogen atoms are there? 2. All right, so the first thing I do is go 14.01 times 2 plus, how many hydrogens are there? 8. 2 times 4 is 8. So 1.01 times 8. Okay, how many sulfur are there? 1. So 32.07 or 06? 07. Okay, and how many oxygen are there? 4. All right, so you have to do it element by element. I know that's a hassle, but it's really not all that bad. Okay, so we punch those all in, so we have 28.02, that's our 2 nitrogens, okay, plus 8.08, that's our 8 hydrogens, plus 32.07, that's our sulfur, and our 4 oxygen atoms. All right, so we got 132.17. I'm just doing it so that you can see that they're separated. Okay, so 132.17 grams per mole. All right, give you another minute or two to get number 5 done, and then we'll go through that together. All right, let's look at number 5. Okay, so I've got scandium carbonate here. Okay, how many scandium are there? 2, so 44.96. Is that what you guys have on yours? Okay, multiplied by 2. All right, how many carbon are there? 3. Okay, so that's 12.01 times 3. Okay, and there's how many oxygen? 9. Okay, so 44.96 times 2 plus 12.01 times 3 plus 16 times 9. Whoop, missed the 1. All right, 269.95. Grams per mole. Okay, everybody okay with that? Do you have a question? No, I'm kind of showing all of my work really drawn out here. I mean, just so you have the examples as simplified as possible. I don't even expect you to show this work when we're doing the actual mole equation. Okay? All right, any other questions on molar mass? Okay. Now, when we have a chemical reaction, we've already talked about balancing and why we do it, but here's what that balancing can actually mean. All right? It could be as simple as it looks, and it could mean that there's 1 molecule of nitrogen gas, okay, 3 molecules of hydrogen gas, and that's going to make 2 molecules of nitrogen trihydride. It could mean that. That's very literal. And in actual fact, would I notice a reaction that involved that small of an amount of stuff? I mean, really? Am I going to see 1 molecule reacting with 3 molecules? Probably not. I can't see molecules. All right? So I'm not going to see it. But it could also mean I have 1 mole of this stuff, which is a much larger number of particles. Agreed? Okay, and it's going to take 3 moles of this stuff to react with it to produce 2 moles of this stuff. Okay, that's the way that you'll treat it in Chem 20 when you start doing something called stoichiometry. Okay, yeah, it's got a funny sounding name, but okay, what stoichiometry is you would be asked based on how much product you got to figure out how much of each reactant you would require. Okay, and you could figure that out based on how many moles of this there are and how many moles of this there are. So you use your balancing, which has to be done right, obviously, and the mole equation, which we haven't talked about, to figure out the mass of everything involved. All right, so that's kind of how you can interpret a chemical equation. It could be literal, 1 molecule, 3 molecules, 2 molecules, or it could be 1 mole, 3 moles, 2 moles. Right? It's always, though, the same ratio. Okay, it's always 1 to 3 to 2. Okay. Right, moving past that. This is Avogadro. I think he called it a mole because he looks like one. Eh? Yeah, he kind of does. He's a odd-looking guy. It's the cut of the suit. The suit cut is terrible. It makes him look like he has no shoulders. Okay? But I guess that's fashion. Fashion is fickle. Okay. All right. Okay, so skipping forward here to the mole equation itself. Okay, I already wrote that down. You have it there. All right. You could be asked to manipulate this equation. That's called algebra. Okay, it isn't anything to be afraid of, because trust me, I'm worse at math than you are. Believe me. I struggled in math like you would not believe. Okay? I got through university math by memorizing the examples from the textbook and writing them down on my final exam and getting part marks for method. I kid you not. Okay? That's how bad I am at math. And I can do this. I teach physics, guys. I can do grade 8 algebra. That's all that's required, thankfully, to teach that. Okay? Plus an understanding of physics. But okay, the math part is actually about grade 8 algebra. If you can move stuff around, you're good. Okay? Now, here's the good news. There are really only 2.5 rules for algebra. Okay? The first rule is, if I want to move something, I do the opposite. And the second rule is, what I do to one side, I do to the other side. These are simple rules. That's why I can do it. Okay? They're simple. The other half rule we'll talk about when we get to physics. It won't concern us for using this equation. Okay? But it is also a very easy rule. Okay? So let's say that the question doesn't ask me to solve for the number of moles, as the equation is set up to do right now, but instead asks me to calculate the mass, little m. How do we get little m by itself? I have to isolate it by itself. How do I do that? By, not little m, but big M, right. Okay, I want to get little m by itself. I'm going to leave it here, and I'm going to multiply both sides by big M. Effectively, that does this, right? It brings big M over to that side. Everybody with me there? Okay, all I did, I see a few confused looks. Okay, I said, if I want to move something, I do the opposite. Right now, I'm dividing by big M. Agreed? So I multiply this side by M. If I have an M on the top and an M on the bottom, they cancel. All right, so this is gone. What I do to one side, I do to, now I have little m by itself. Okay, so that's all I've done. Okay, and honestly, that's the only manipulation of this formula you'll have to do. Right, because you never have to solve for big M. You get it from where? It's what we've just been working on. Big M is molar mass. You get that by adding things together from the periodic table. So you're never going to have to use this formula to solve for it. That's the only manipulation of the formula I have to do. All right. Now, something I don't want to see. My little rant. I'm going to rant here. Okay. I don't know who teaches you that crap, but if I find out, I will kill them. Okay? Because it's crap. And it's a crutch. And here, no, it doesn't help. Here's why it doesn't help. Okay? You can argue with me all you want, but you're wrong. Okay? That triangle only works for a formula with 3 variables that sets up just like this. It will only work for that. Okay? That means it will only work for 2 of about 24 formulas you're going to use in this course. Which means if you have been depending on this to do algebra, you are royally screwed. So, you will learn how to do algebra because I will teach you. Okay? I will, because you should have learned it before. Someone should have taken the time to teach you this before. Okay? If they didn't, it was because they were lazy. And I want to hurt them. Okay? Because it makes extra work for me when you should already know how to do this. Okay? So, this is a crutch, guys. And if I'm going to teach you to walk, the first thing I got to do is kick the crutch out from underneath you. Okay? You may not use triangles. Okay? Here's why, guys. The second formula you're going to learn in physics is this one. It's got 4 variables in it. Guess what? No triangle for that. Okay? No, it doesn't work. Okay? How about this one then? Kinetic energy. Okay, how about this one? Got a triangle for that? I bet you get really, really confused when I give you this one. Okay? So, your days of using triangles are coming to an end. Because triangles suck. And they don't work. Okay? So, if you're needing help with algebra, please come in and see me. I can teach you to do algebra. It really isn't hard. Okay? I don't know why people just shy away from doing it, but it's not hard. Like I said, guys, there's 2.5 rules in algebra. Okay, that's all you have to remember is if I want to move something, I do the opposite. What I do to one side, I do to the other. Okay, the half rule is move what's not attached first. We'll talk about that in physics. You don't even need to know it yet. Okay, that's all you have to remember to do algebra. It's easy. Okay, it really is. You don't need triangles. Triangles are not your friend. Okay, all right. Here's some more good news for you. There are only 4 ways that I can ask you a mole equation question. Only 4. Okay, what I'm going to do today, tomorrow, and Monday is I'm going to show you examples of each of the 4 ways. So by the time you write the test, you will have 3 examples of each of the 4 ways that I can ask you a mole equation question. All right? They are not very hard. Okay? The first 2 are really easy. The second 2 have 1 extra step. Okay? And they're also not very hard. Okay? Trust me. Okay? All right. You do want to show your work here. Okay? The reason you want to show your work is I'm a person who believes method is important, and thus I give marks for it. Okay? So the first thing you want to do when you see a problem in science in general is write out what we call your givens. That is, what did the question actually give you? All right? So this one says, how many moles? All right, so first off, this question told me I want to know this number. What part of the mole equation represents moles? N, right, the only thing that doesn't start with M. Yeah, okay, all right, N equals number of moles. I don't know what that is. That's what the question wants me to find. Okay, of calcium chloride. Since I know the formula or I know the material, what can I find with this? Molar mass. That's capital M. Okay, so I'm going to say CaCl2, and I'm going to figure that out right now. Calcium is 40.08, and there's only one of it. How many chlorine are there? 2. Okay. Okay, that should be 110.98. Is that right? You can double check, but I'm pretty sure that's right. Okay, 110.98 grams per mole. I didn't do that in my head. I remembered it from this morning. I told you, I'm not good at math, but I have a really good ability to memorize things. Okay, that's so I can really impress people. They think I'm really good at math, but I just memorized it. Okay, all right. So I have big M, and they tell me 90 grams. That's little m. Okay, I have 2 out of the 3 parts of the mole equation. Can I calculate N? Yes, okay. So N equals little m over big M. Plug in my numbers. So that's going to be 90 grams over 110.98 grams per mole. And I wouldn't even expect that you would write the units in here. Okay, you don't have to do that. All right, so N's going to be, what is it, 0.8 something? 0.8? Okay, 2 decimal places is lots. 0.81. What are my units? Nope. I took grams and divided by grams per mole. Grams goes away and leaves me with? All right. Mole. 0.81 mole. Okay, here's where you get marks. 1 mark for the givens, / calculating your molar mass. Okay, 1 mark for your work because you didn't have to manipulate the equation. If you had to manipulate the equation, there'd be another mark here. Okay, and 1 mark for your answer. Okay, so we're looking at, that's the easiest kind. That's a 3-mark question. Okay, if I was feeling really generous, like maybe on a final exam, I might also give you a mark for picking the right kind of formula. In other words, I'm testing you on a whole bunch of things and you recognized it was a mole equation question and that's worth a mark. Because this is the only question you'll do any math with, you probably won't get that mark. Yes, that's what I mean by that, which is what we're going to do in the next one. Okay? Anyone need that one anymore? 1 second. Okay. We'll see. Can I move on? Okay. All right. Here's your second type of mole equation question. And again, guys, I would write these down. If you're not writing these down, these are your examples, okay? Right? You're only going to get so many of them. And like I said, the ones that are on your test, other than what material and what numbers, the method will be exactly the same. Okay? This question asks me, what's the mass? All right, so this question is asking me to calculate little m. It'll be my unknown for this question. What is the mass of 4.5 moles? What did they just give me? N, right. This is N, moles, okay, of magnesium bromide. That'll help me calculate this thing, right? Okay, the compound is always going to go with big M. All right, magnesium bromide. Good, thank you. Good. Okay, how important is it to get the formula right here? Really important, because if you forget to drop and swap an ionic compound, you will not multiply the mass of bromine by 2. As a result, you will not get the right molar mass. Further to that, you will not get the right answer, okay, because you won't have the right molar mass because you didn't have the right formula. You got to make sure that you can do that thing we learned the second day, writing formulas. Kind of an important skill, okay? All right. So magnesium's what, 24.31. Okay, plus how many bromines? 2 plus 79.9 times 2. Okay, again, I wouldn't expect that you would necessarily show me this in a mole equation question. I'm just showing it all so you have it there. Okay. All right, so 24.31 plus 79.9 times 2. All right, the molar mass of this stuff is 184.11 grams per mole. Okay, I have little n, I have big M, and I'm looking for little m. So n equals little m over big M. I need to isolate what I'm looking for. How do I isolate little m? Multiply both sides by big M, right? Okay, now I can plug in my numbers. Okay, so that's going to be 184.11, big M, my molar mass, multiplied by the number of moles, 4.5. Okay, and that should sort of make sense. If this is the mass of 1 mole, and I have 4.5, multiplying them should give me my total mass. Agreed? Right? If it was like you were trying to figure out if you were over the maximum load of an elevator, okay? If there were 6 people in the elevator and they all weighed 200 pounds, not that they would, but okay, and they all weighed 200 pounds, you got 1,200 pounds of people in there. If the maximum load of the elevator is 1,000 pounds, you best get somebody out the elevator. Okay? All right. So, my overall mass, 828.50, two decimal places, 50 grams. Okay, marks for a question like this. Again, for givens / calculating the molar mass. Okay, you'd get a mark for the manipulation of the formula. You'd get a mark for putting the numbers in correctly, and you would get a mark for the final answer. So that would be a 4-mark question. Okay, so those are the 2 easy ones. Okay, they only have basically the 1 step, okay, and that is to use the mole equation. The next 2 will have 1 extra step involving Avogadro's number. Okay, that's that 6.02 times 10 to the 23 thing I showed you at the beginning. Okay, you either are going to be multiplying by that number or dividing by that number. That's all you'll ever do with it. Okay, that's the extra step. 1 question you divide by it, 1 question you multiply by it. That's the extra step. It's nothing terribly complex. Okay, can I move on to the next one? All right, the way you'll know if you have to use Avogadro's number is the question will specifically talk about particles. That is, it'll ask about molecules or atoms. Okay, in this case it's going to talk about molecules because we're dealing with a compound, silver nitrate. Okay? It wants us to calculate how many molecules there are in 600 grams, that's little m, of silver nitrate. What can I use that to find? Big M. Okay, now silver nitrate. Here's silver. It's +1. Okay, nitrate is NO3. It's a -1, so that's already dropped and swapped. Okay, again, getting that formula right is pretty crucial here. I would often see this written as silver nitride, Ag3N. Okay, not the same thing. All right, so this stuff's really heavy, like 107 or something like that. 0.87, all right, yeah. 107.87, that's my silver, okay, plus how many nitrogen? 1. And how many oxygen? 3. Right? I mean, if we're looking at this, there's no number next to silver, there's no number next to nitrogen, but there is a number next to oxygen, okay? If there was brackets, then the number outside the brackets would apply to everything in the brackets, okay? Just like it does in math, right? Okay, so when we add those up, 169.89. Again, I kind of remembered that from this morning. I didn't do that in my head. Okay, 169.89 grams per mole. Okay, here's why you want to show your work. You got 1 mark right now, okay? If you don't remember what to do from here, at least you got 1 mark, okay? If you leave it blank, you get nothing. I can't give you something for nothing, okay? But if you got at least this far, and you should be able to always get this far, okay, you're going to get at least 1. But here's why I always want you to put your givens down. If I have little m and big M, what can I calculate? N, and I probably should, okay? So that's what I would do. Even if you weren't sure, that's most likely the next step because it's the only thing right now you're capable of getting. Yeah. Well, yeah. 107.87 plus. That's 16 times 3. 79.88. No! 169.88. You're right. I'm going to go with that. Okay. All right. So now I'm going to calculate N because it's the next thing that I can logically calculate. Do I have to do any manipulating or is this already set up? Already set up. Just got to plug in my numbers. Okay. 600 grams divided by 169.88. Okay, so I have 3.53 moles. Okay, now if I didn't know where else to go from here, I've got 2, maybe even 3 marks under my belt. Okay, even if I had no idea where to go from there, at least I got 3. All right, now, I told you that anytime it mentions or asks you to get molecules or gives you molecules, you're going to be using Avogadro's number in some way. Either you're going to be multiplying by it or you're going to be dividing by it. So what we have to remember is, what does Avogadro's number tell me? It's the number of particles in 1 mole. 1 mole. Okay? Now, if that's the number of molecules in 1 mole, and I have 3.53 moles, how would I figure out how many molecules I have? That times Avogadro's number. Okay? Because if I asked you this, you would do it automatically. You have 3 dozen donuts. How many donuts do you have? 36. How'd you do that? You went 3 times 12, right? I told you had 3 dozen. You know there's 12 in a dozen. You went 3 times 12. Well, you're doing exactly the same thing here. I have 3.5 moles. This is how many there are in a mole. Multiply them, and it gives me how many I have. Okay? So, to get the number of molecules, okay, I'm going to take my number of moles, n, and multiply that by 6.02 times 10 to the 23. Okay, so 3.53 times 6.02 times 10 to the 23. The next natural question is, how in the hell do I put that in my calculator? Okay, so here's how. It depends on what kind of calculator you have. If you have a TI-80 whatever, okay, you put it in like this. You put it in brackets. In fact, this is true for any calculator. If you are going to have to put exponents on something, you start it out in brackets. So I have brackets 6.02. And then I hit the second function, and I hit the comma button, because above the comma are 2 little e's. Okay? That little e stands for times 10. And the next number you put in is whatever power 10 was to. In this case, that's 23. And you close up the brackets. The importance of the brackets is this. If you don't bracket this up, your calculator will do order of operations, and it'll assume everything after the 23 is part of the exponent, which will give you this gigantic number usually. Okay, not that this number isn't already going to be gigantic, but okay, it'll give you an even more unfathomable number. Okay, now, if you don't have a TI whatever, okay, look for one of 2 buttons, EXP. Okay, you may have an EXP button, or you might have the 2 little e's button. Okay, either way, that is your exponent button. All right, so you would go brackets 6.02, hit that exponent button, okay, and then 23 end bracket. Okay, if you're having trouble with your calculator, can't find it, let me know, and I'll come around and help you in a little bit. Okay, even your phones, if you flip them to the side, the scientific stuff comes up, okay, and they have that button in them as well. Okay. Well, as long as it doesn't end up being bigger than 10, because if it's bigger than 10, you have to add that to the exponent. Okay, it's scientific notation. It's always between 1 and 9.9. Okay, the base number is. Right. So we do this, and then we multiply that by 3.53. Okay, so we get 2.13 times 10 to the 24. Right, number got bigger. Okay. All right, now I forgot the number. See, 2.13 to the 24. What units should I put on that? What was I finding? Molecules. Okay, so a question like this, guys, marks-wise, we already said here, here, and here, right? You would get a mark for recognizing you had to use Avogadro's number and using it in the right way, a mark for your answer. Probably 5-mark question, 4 or 5. Yeah. Yes, because 3 times 6 is greater than 10, so it shifts up one more exponent, right? All right, last one. In this one, it's the opposite. They tell me, here's how many molecules you have. Now figure out the mass of it. Okay, so essentially I'm going to do exactly what I did in the last question backwards. Okay, if I want to find the mass of something, I need the number of moles and I need the molar mass. Okay, now this question tells me what material I'm dealing with, so I can find the molar mass right away. Okay, so we'll write down big M here is diphosphorous tetraiodide. Okay, and I'll calculate the molar mass of that. Was it 100 and something? It's heavy. 126.9. Okay, 571.74 grams per mole. Okay, and the other thing I'm given is the number of molecules. Okay, so all right. Anytime they mention molecules, I know that Avogadro's number is going to come into play. How can I use Avogadro's number here to get N? Divide. Okay, if I know how many molecules I have, and I know how many molecules are in a mole, if I divide those numbers, that'll tell me how many moles I have. Okay, in the same way that if I told you you had 48 donuts and asked you how many dozen donuts you have, you would go 48 divided by 12, because that's how many there are in a dozen. Okay, well, you're going to do the same thing here. Here's how many molecules I have. Here's how many there are in a mole. Divide the two, and I'll be left with how many moles I have. Okay, so number of moles, okay, is going to equal 1.54 times 10 to the 25 divided by 6.02 times 10 to the 23. It'll come back up. Just hang on. Whoop. Okay, got to put it in brackets. Sorry, I'll put this down so you can copy that. Okay, so we'll just put in here. Okay, number of molecules divided by Avogadro's number, Av's number. Okay. All right, so we said you always have to put this in brackets. So 1.54 exponent 25 divided by Avogadro's number, which also has to be in brackets. All right, so I have 25.58 moles. Okay, that's what it's telling me here. Okay, so now I know N and I know big M. Can I calculate the mass? Yes, I can. Now I go back to the mole equation. Like we said, is basically what we did in the last question in reverse. Okay, so N equals little m over big M. Multiply both sides by big M. That gets little m by itself. So little m is going to equal, okay, 25.58 times our molar mass up here, which was 571.74 grams per mole. Okay, is that a lot? Yeah, it's 14.6 kilograms of this stuff. That's what we got. Okay, we had a lot. 25 moles is a lot. Okay, so we've got 14,625.9 grams. Okay, so Mark's distribution on something like this. Givens. Okay, and then you would get a mark here for using Avogadro's number. Okay, you'd get a mark for manipulation of the formula. You'd get a mark for plugging in your numbers, and a mark for your final answer. 5 marks. Okay, Bridget, you had a question? Figured it out? Okay, David. 25.58. Yep. You want the calculator back up? Okay, so the 25.58 was the number of moles, okay? We calculated that up here, okay? We said we have this many molecules. We're dividing it by how many molecules there are in a mole, okay? When I take the number I have and divide it by the number in a mole, it leaves me with moles. Okay, just think back to the donut example. If I have 48 donuts, how many dozen do I have? 4. I know, but I'm trying to give you a simpler analogy for it. Okay? If I have 48 donuts, and there are 12 donuts in a dozen, if I go 48 over 12, does it tell me how many dozen I have? Okay, this is the same thing. This is the number of donuts I have. This is how many there are in a dozen donuts. This is the number of moles. Okay, so I go from molecules per mole, I get left with moles. Okay, in the same way that 48 over 12 donuts per dozen leaves me with dozen. Okay, Graham? No, it doesn't. He just picked it. I have no idea why, except that maybe he looks like a mole. Maybe that's his nickname. Hey, Moley, come over here. I don't know. I don't know. Yeah. I don't know why he picked it. It seems weird to me too. All right, is that making a little more sense, Sadie? Okay, so like I said, we're going to have some time to practice this stuff. We're going to go over some more examples each day. Okay, you're going to get some practice doing them. We'll probably forego a quiz on this stuff tomorrow. We'll probably forego a quiz entirely tomorrow. Okay, so we'll just not have one. I know that breaks all of your hearts. But you do have a lab report due tomorrow, so make sure you have that done. Okay. All right. Can I move on here? A minute? I don't know if I have a minute. Okay. 14625.9. Okay, so for the first one here, okay, they want me to find the number of moles, so they're asking me to find N, all right? They tell me what material I'm dealing with, so I can calculate big M. It's carbon dioxide. So that's going to be 12.01 plus 32. Okay, so we're looking at 44.01. That's 2 times 16. Okay, so 44.01, and that's going to be in grams per mole. Okay, and then they tell me little m, because that's always in grams. Okay, and that's something you're going to have to remember. Okay, little m is always in grams. Big M is always the one you get from your periodic table, and it'll be in grams per mole. N is always going to be in moles. Okay, all right. I've got big M and little m, and I'm supposed to find N. Well, luckily for me, that's what this equation is already set up to do. So I don't have to manipulate or anything. All I have to do is plug in my numbers. Okay, so I've got my 150 grams, and I'm dividing that by 44.01 grams per mole. Well, what happens to the grams? They cancel each other off, right? Grams divided by grams cancels, and I'll be left with the units I want. Agreed? Moles. All right, so all I got to do is divide 150 by 44. Oh, it's got to be on. Works a lot better that way. All right, so we're looking at 3.41 moles. Okay, does that make sense? Okay, like I said, that's the easiest one. Okay, first one's the easiest kind. Okay, try number 2.